In the previous lecture, we created these two new branches, the dev branch and the test branch. We of course already had by default the master branch, but now we have the three branches that we're going to be working with. And like I mentioned, the idea is to commit most of the changes to the dev branch. Once a new version is ready to be tested, to merge those changes into test. And once those changes are ready to be deployed to the users, to be merged into master. So that is why I will start right here with the dev branch selected and navigate back to Visual Studio to make some changes. So let's say that the thing that we're doing, we're coding a new feature, and that feature is simply to add a button in here. And having the button, I am going to add some text, click here, and maybe create a clicked event handler in here. So I will create the event handler over here in the C# file. And all this is going to do is display an alert. So we have changes to these two files. And let's say that this is the entire feature. And because this is just a test, we're not even really going to be executing this. All I really want to do is head back to the terminal, where if I execute git status, I am going to see those changes. And I want to commit these changes to the dev branch. So far we have only been committing to the master branch. Now we're going to be committing to the dev branch. And those things that I commit here in the dev branch are only going to exist in this branch, at least until I merge them to another branch. So what I will do in here is execute git commit with both the A and the M flags in here, and a message of add button. Execute this, and now all of those four files with all of their changes have been both staged and committed to the dev branch, and they continue to exist in here. But let me show you what happens if I check out to the test branch, for example. I am now on the test branch, and of course, all of this is also known by my IDE. If I navigate back to the IDE, it knows that I am now on another branch. You can see that indeed the change is not here because that change does not exist on the test branch. It is only until we check out back to the dev branch, and if I head back to Visual Studio, I see this change again, and it is on both of the files. So you can see how we can commit to one single branch and the other branches are not going to have that change. Now, what do we do if we want these changes to be on the test branch? Because let's say that the feature is ready and we want the test team to start using this new feature and see if there is anything that can be improved. In that case, what we have to do is merge the dev branch with the test branch. And for that, all we have to do is execute git merge. Now, git merge, before you execute anything, has to be executed from the destination branch, that branch that will eventually have the changes. So I will first have to execute a git checkout to test. It is in this branch where I want to merge the changes that are inside of dev that are not yet inside of test. And so once in test, I can execute git merge and select the branch from which I want to merge, in this case, dev. If I execute this, you can see that indeed the changes in the SAML and C# file for main page are among those changes that were missing from test and that have now been merged inside of test. If we head back to Visual Studio, we still see these changes because they are now part of the test branch as well. One thing that you can execute to make sure that this commit was indeed made is the git log again. You can see that the most recent commit is pointing to both test and dev, meaning that both branches are in this commit. Both have the exact same code. However, so far, Master does not. Master is one commit before, meaning that all of the changes that were made in the most recent commit are not yet part of the master branch. But we are in the good track. We have made some changes to the dev, merged them into test, and now let's say that we're going to be testing whether or not this works. Let's say that the test team decides that this message is not the best message possible. I'm going to change this to be success, and instead of some message, I am going to set this click was successful. Having changed this message, I can commit the changes directly to the test branch. And by the way, I am here on the log, and I can check the previous commits like this and click Q on my keyboard to end this. So I can execute git commit with both A and M and set the message to change alert text like this. Execute this, and now this is part of the test branch. If I execute git log, I can see that test branch is ahead of the dev branch because this last commit is not part of the dev branch. It is only part of the test branch. And we can confirm this by executing git checkout dev, navigating back, and seeing that indeed the display alert is still displaying those old messages. Now let me navigate back to the test branch, and the test branch contains the new version. So the test team has made some changes, and they decide that these changes are ready for the public. We are ready to release them to the public. That would be the time when you merge everything into master, finally. And again, just like we did with test, first we have to check out to master. And from master, I can execute git merge and merge the test branch. All of the changes that weren't on the master branch but already were in the test branch are now going to be added to the master branch as well. So if we navigate back to Visual Studio, we see that the most recent message is being displayed in here. And if we execute git log, we can see that the most recent commit, the one that updated the alert text, is on both the test and the master branch. This would be the entire flow that you will follow when you add new features to your application. First, you commit everything to dev. If some changes are required, you can make them directly from test, although that is not too common. But once that is ready, you can finally merge those changes to master. And at that moment, when the merge happens, the CI/CD process would be triggered. Of course, that is not triggered yet. We haven't done anything about CI/CD so far. But now the structure of your branches and the flow that you should follow should be clearer to you. Now, before moving forward to getting all of these changes, all of these commits, all of these branches over to GitHub, where the actual CI/CD process foundation is going to be set, let me merge all of those new changes to dev so all three branches are on the same page right now at the end of this process of adding a new feature. So for that, all I am going to do is navigate over to or switch over to the dev branch. And I am going to execute git merge with whatever is on the test branch that is not on the dev branch. And of course, that would mean that the change that I made to the CS file is going to be added. So right now we can see that we are on the dev branch and the main page is still displaying that new version of the message. And of course, if we execute git log, we see that all three branches are on the same page. Now, this doesn't always have to be the case because maybe you are developing some new feature on the dev branch and the master branch may be 2 or 3 features behind because they are being tested. That is okay. I just wanted to finish up this lecture with the 3 branches on the same page so we can start from there in the next lecture where we're going to send all of this over to GitHub, where again, the foundation of the entire CI/CD process is going to be set.